You for the absolute values inequality quiz. So we'll start with number 20. These are the same problems that are on the paper that we gave you. I just wrote them out so that we could write out all the steps and make it nice and clear for you. The big rule I'd say for these is that when you have something in absolute value, you're going to eventually turn it into two separate inequalities. But you can't do that until everything that you're solving for is inside the absolute value. So in the case of number 20, everything that we have to worry about is in the absolute value. There are no numbers outside of it. So this one is actually ready to be split into two separate problems. So I need to decide what kind of problem I'm going to separate it into. This is going to be a less than symbol right here, which means that we'll have an and split. So then on this side, I'm going to recopy everything exactly as it is, except that I'm going to leave out the absolute value symbols. On this side, I'm going to do the exact same thing, except that in this case I'm going to turn the inequality symbol around to make it a greater than, and I'm going to change that sign of that number to make it -2. Alright, then also I need to solve these like separate problems. So in this case I'm going to divide both sides by -2. So right away this takes us back to an old inequality problem that we would have done a long time ago, which is when you divide by a negative, even in this case, the numbers will cancel, but you have to remember to turn that symbol around. So this will be a greater than symbol, and 2 divided by -2 is going to leave us with a -1. So we still have the and then once again over here I'm going to divide by -2. So even though I just turned that symbol around a minute ago, I'm going to do it again here because I'm dividing by a negative. So this is going to become a less than again. This is actually -2 divided by -2 is +1. So if I look at what my answer says, it says that my answer has to be greater than -1 and less than +1. That makes sense. It has to be between those two numbers. So on our number line, when we finish this, I'll put a 0 here. I can put -1 right here and +1 here. Since they're both regular inequalities, they're both open circles, and the shading would be in between, because if I went greater than, it would go that way, and less than on this one would go this way. But it's an and, so I'm going to assume the shading is in between the two numbers, like that. And that's your final answer to number 20. So we move to number 21. It's not much different. In fact, it might actually be a little bit easier. Again, everything that we have here is in absolute value, so this is ready to be split. The greater than symbol means that it's going to be an or, and if I split this, it'll be x plus 5 greater than or equal to 2, recopying everything except the absolute value symbols. And then on the other side, once again, I'll turn the symbol around and change the sign of the number. So I'm going to use a less than or equal to this time and change it to -2. So if I solve this, it's a pretty easy solving. Just subtract 5 from both sides. This one is going to have greater than or equal to -3, or on this side, if I subtract 5, less than or equal to -2 minus 5 more is -7. So since it's an or, I should expect that the inequalities will go off in different directions. So -3 and -7, they're both over here. -3, -7. They both have equals to symbols, so that means solid dots rather than open circles. If I think about it, greater than or equal to -3 would be this way. Greater than goes to the right. And less than -7 would be on this one, this direction. So you can see I have shading going off in opposite directions there, as opposed to the and problem where the shading was in between. So those are two pretty classic absolute value inequality ones. So let's go into something that might have potential for some mistake in number 22. What I would suggest you do for this problem, just to make it a little bit more Algebra 1 as opposed to Algebra 2, instead of having 40 here, let's change this number to, I'm going to make it a more positive number, so let's make it 80. So instead of having 40, I'm going to make this an 80. Because with a 40, it's more of an algebra 2 problem. And the reason why is because the graphs don't always work out the way you would think. And that would be something you would focus on a little bit more in algebra 2. So let's just make it an 80 so that it'll be like an algebra 1 problem that you would be asked to do. And like something that would be on the keystone. Anyway, so in this case, what I would say is, if you notice, the 8x is in the absolute value, but the 56 is not. So before you can do any of the splitting that we did in number 20 and 21, we have to make sure that we have everything in the absolute value by itself. And that plus 56 is going to have to go away. So I'm going to subtract the 56 away from both sides. That'll cancel that out. And that leaves me with an absolute value of 8x greater than or equal to 24. So in this case, what I want to do then is, now that I do have the absolute value part by itself, I can split it. So this will be an or because of greater than. So 8x greater than or equal to 24. On the other side, 8x, I'll turn the symbol around to make it less than or equal to, and I'll change the sign of the number, negative 24. So to solve these, I divide by 8 on both sides. This one's going to be greater than or equal to 3, or x is less than or equal to negative 3. Because negative 24 divided by 8 is going to leave me with a negative number. So it's time to shade. Since these are OR problems, put the 0, negative 3, and 3 on the number line. This one says greater than or equal to 3. That's a solid dot and shade to the right. This one is less than or equal to negative 3, which is a solid dot and shade to the left. So once again, our graph reflects an OR-like graph where they go off in opposite directions. So we go on to number 23. Starting to see a pattern here. These ones, again, have everything in the absolute value, so we'll need to separate it as it is. There's no need to do anything else first. We have to separate it now. Or, so 7x plus 14 greater than or equal to 35. Or the same thing on the other side, 7x plus 14, but it will be less than or equal to negative 35. So if I solve these, I'm going to have to solve this one separate. I'll take the 14 away from both sides. And that leaves 7x greater than 21. And then I'll divide by 7. X is greater than or equal to 3. And then I work on the other side. Subtract 14 from both sides. 7x less than or equal to negative 35 minus another 14 is going to take me down to negative 49. Then I divide by 7, and I get x is less than or equal to negative 7. So once again, this is an OR graph, so we should see shading going in the opposite directions. I have 3, and I have negative 7. Greater than or equal to 3 would mean a solid dot and shading to the right. And less than or equal to negative 7 would also mean a solid dot but shading to the left. So our graph would look like that. Okay, let's keep going. We'll go on to number 24. Number 24 looks pretty simple, but I can see some potential for a mistake for some people, so let's make sure that we clear up any questions here. Again, everything that's in the absolute value, everything is in the absolute value, so we're ready to split it. So some people will tend to try to turn that to a positive, but you don't want to do that. You want to just keep the pattern we've been doing and split this problem right away. So this is an OR. So we have negative 0.05x greater than 1 or the same exact thing, negative 0.05x, but it would be less than negative 1. And so when we go to solve this, we'll have to divide both sides by negative 0.05. And again, just like the very first problem, we are dividing by a negative, so we go back to the first rule of inequalities, which is anytime you divide by a negative, you'll turn the symbol. So this one's actually going to turn to a less than. And then 1 divided by negative 0.05 is actually going to be negative 20. Or, let me do the same thing on this side. Divide by negative 0.05. And once again, we're going to have to turn that symbol around. From the less than that we just turned it into, we'll have to turn it around again because we're dividing by a negative. It would be greater than, and negative 1 divided by negative 0.05. The two negatives turn out to be a positive and make this positive 20. So since this is an OR graph, we should expect our numbers to go in opposite directions, or our arrows, our shape. And they're both open circles. Less than negative 20 would be to the left. Greater than 20 would be to the right. So I would say that the potential for mistake in this one is really in this part where you're dividing by a negative and having to turn the symbols once again. Because if you don't do that, you're going to get shading that goes in the wrong directions. Alright, let's work on number 25. Here again, if we look at this one, another potential for mistake, there's a 6 outside of the absolute values. That needs to go away first. Sometimes people tend to try to distribute it, and it would be okay if these were parentheses, but since this is absolute value, it's better to get rid of the 6 rather than distribute it. So let's just divide this whole problem by 6 so that it would cancel out. And I'll have absolute value of 2x plus 5 greater than 11. So we're going to turn this into an OR problem because it is a greater than. So this will be 2x plus 5 greater than 11. And then the other side, 2x plus 5, but we'll switch that symbol around again to make it less than and negative 11. So we solve these separately. We'll subtract 5 away from both sides. 2x is greater than 6. Divide by 2. X is greater than 3. The other side again, subtract the 5. 2x is less than negative 16. And divide by 2. X is less than negative 8. So since we have an OR problem again, once again we'll suspect that the shading will go in opposite directions. We need negative 8. Positive 3 on the number line. Open circles on both. The shading should go greater than for the 3 and less than for the negative 8. Alright, last two of these. Number 26, it has kind of what I would call maybe the most difficult problem on here because of the potential for mistake in the whole thing. For number 26, there is a negative 8 out here, much like there was in number 25, a number that we need to get rid of. So we should divide it away like we would any of the other ones. But you're dividing by a negative, so when you divide an inequality by a negative, you're going to need to turn that symbol around. Right here. So we're going to make this a less than. 48 divided by negative 8 is negative 6. So this is the point where you decide whether or not it's going to be an and or an or, when you're ready to split it. So the absolute value is by itself, so now we're ready to split it. And because the symbol at this point is the less than, this is an and. So we write x plus 4 less than negative 6. And on the other side, x plus 4, we turn the symbol around, make it greater than, and we change the sign to positive 6. So if we look at this one, we'll subtract the 4. This is going to be x less than negative 10, and over on the other side, subtract 4, x greater than x greater than 2. Okay, so this is a point where this would become an algebra 2 problem, because what we have here is something called a no solution, because there are no numbers that are both less than negative 10 and greater than 2. So the situation that we run in here is something that you would focus a little bit more on in algebra 2, which is when you solve one of these and there actually is no solution. Because again, there are no numbers that fit both of these qualifications. There are no numbers that are both less than negative 10 and greater than 2. So I don't know that you're going to see one of these on your test, but the reason why that is the reason why I solved it is I wanted you to see how you actually do the solving. But for our purposes, I don't think you're going to run into any that are no solution, because that's more of an algebra 2 like problem. But don't worry, next year it's coming. So alright, let's work on number 27, our last one. We have a 6 on the bottom. This is dividing by 6. Again, that is not in the absolute value symbol, so we need to make that go away. So what I'm going to do is multiply everything by 6. And what will happen is the 6's will cancel, and then I'll get the absolute value part by itself, and over here will be equal to 60. So from this point, this should probably be a pretty easy split by now. The less than would mean and. This is 8x plus 4 less than 60. And on the other side, 8x plus 4. We turn the symbol around and make it a negative, like that. So let's subtract 4 from both sides. 8x is less than 56. And divide by 8. X is less than 7. Over here, subtract 4. 8x is greater than negative 64. Divide by 8. X is greater than negative 8. So this one works, see, because we have numbers that are less than 7 and greater than negative 8. So this one is going to be how they would show up on your test. Pretty standard and problem, where we have a 0 here, negative 8, positive 7. Both of them are normal inequalities, so they have open circles. But the shading is in between, because again, less than 7 would go this way, and greater than negative 8 would go this way. But you want the area where they both be, which is in the middle. Like that. So I would say, if I were you, I would definitely look at number 27 as a good example of a test question for an and problem. Alright, let's look at the last set of types of problem you're going to work with, which is how to take a graph and write it as an inequality. So I'm going to keep those graphs up at the top, and then we'll write them down here, our answers. So if I look at the first one, what I notice is shading that goes in opposite direction, which tells me that's going to be an or problem. And so when I write that, I look at the left one and I say that, okay, this is at negative 5 and it's shading less than. So I'm going to say less than negative 5. And because it was a closed dot, I'm going to put an equal to symbol under it. For the other side, this is at positive 3 and the shading is greater than. So it's greater than 3, like that. And it's an open circle, so I leave it as a regular inequality. And that's it for number 28. Number 29 is the same idea. It's an or because we see shading in opposite directions. This one is at -6 and less than, so we have less than -6. It's a regular inequality, so I leave it here, an open circle, regular inequality. And the other one is at -1 and greater than. So we would say greater than -1. Because it's a closed dot, I'll make it an equals to. So let's look at number 30 and number 31. Because you have shading in between the numbers, that's going to indicate an and inequality. What I want you guys to get into the habit of writing is writing it to indicate that your solutions, your x, is in between those two numbers. And the way you represent that is an x with two less than symbols on each side, like that. And then all you have to do is write the numbers that they're in between, -2 and 6. And then if you have an open circle, leave the inequality next to that number alone. If you have a closed dot, like we do on the 6, make that inequality have an equals to symbol. So if you look at our shading, what it means is that the answers are between -2 and 6. And that's what this indicates. X is between those two. You can read it as x is greater than -2 and x is less than or equal to 6. So let's do 31 the same way. Again, I see shading between two numbers, so that should make it pretty easy to write the x and the two inequalities. And then it's -4 up to +3. So -4 on this side, 3 on this side. The -4 has a closed dot, so I should put a line there. And the 3 is an open circle, so it stays alone. That's it for your solutions for the review. If you have any questions, you can come see us before your test.